Okey, situasi seterusnya yang kita nak tengok dalam uniform circular motion adalah apabila car on the road. So, car on the road ada dua type. Satu dia berada dekat flat road. Jalan tu mendatar sajalah. So, jalan mendatar kalau dia bergerak lurus, dia tak ada masalah lah. Dia tak ada uniform circular motion. Now, bila jalan yang dilalui itu berselekoh. Macam ni lah. Berselekoh. So, let's see one of them. So, saya nak ambil yang bawah ni je dulu. Right? Crop. Okay, saya nak ambil yang kat bawah ni je. So, imagine that you have a car here. Ada kereta dekat sini. Okay, this car kat sini. Dia daripada atas ke daripada bawah ke sama je lah. Dia atas ke pun sama, daripada bawah pun sama. What happened here, you have a car here. And then this car is actually moving in a circular path. Tapi dia separa saja. So, circular path dia macam ni. Dia lebih kurang something like this. The path jadi macam ni. This is your path. So, waktu dia bergerak daripada sini ke sini, sebenarnya dia melalui circular path. It is part of the circular path. What happened here, if you look at your car daripada depan, so kita tengok daripada depan macam ni kan, awak akan dapati your car is something like that. Now, kita nak cari what is the centripetal force yang menyebabkan kereta tu boleh lalu awak punya selekoh. So, imagine that you are in the corner. Cuba ingat balik bila you berada di corner, you punya body is tend to move outward. Betul tak? Dia akan cuba untuk bergerak ke sana. Okay? This is kita panggil sebagai tendency of motion. So, bila ada tendency of motion, awak akan ada frictions. Sebab saya tak kata pun road ni frictionless kan. So, must be dia ada friction. Your friction mesti melawan pergerakan. So, tadi kita dah tengok pergerakan kita seolah-olah nak ke sana. But due to the friction, kita stay on the circle. So, friction mestilah ke sana. So, your friction. And before that, I forgot to say that your A is something like this lah. This is your A. Sebabnya your A is toward the center of the circle. So, your friction is in the same direction as your A. Friction awak dia sama direction as A. So, this is your friction. And then, you akan ada mg. Di sini, you akan ada mg. And also, you akan ada R. Okay. So, your A is something like this lah. Kalau kita tengok daripada depan, your A is something like this. So, now, your A C is in x-axis, so that your FC should be equal to summation of Fx. Now, in the x component, we have only friction. Okay, tak ada friction sahaja. And then what happened here, your FC is equal to MAC. Your AC is positive, since it is to the right. You will only have FC equal to MAC. Okay, since Fx, summation Fx is equal to MA, you will have summation of Fy is equal to 0. So, why saya sebut pasal ni? Because if you can see that friction is mu R equal to MAC, kan? So, sometimes you will need this R. So, this R, you can get it from the Fy equal to 0, which you will have R minus mg equal to 0. You will have your R equal to mg. So, if you have your car in the second curve, something like this, on upward here, kat sini kan, bila kereta dekat sini, you will get the same equation. You can prove it, you will get the same equation. The second situation, if you are in the, kita akan consider hanya dekat frictionless banked curve road. Okay, I think you dah pernah tengok some of the race basikal kan, lumba basikal, yang curve dia will look like something like this. Macam ni. Kalau tengok kereta ni kan, kereta ni berada dekat atas landasan yang sengit. You can see that landasan ni sengit. Okay, so you have something like this. Right, you can see. Then dia akan ada theta lah. Right, so if you see this, let's say you have something like this. And then you have car here. tengok daripada depan car tu, you can see this is your car. Right. Saya nak padam ni dulu. Okay. Okay, so then you have theta here lah. Theta, you akan ada something like this. Then car ni kan dia kan tadi kan dia berjalan, dia akan saya nak guna balik. So dia berjalan ni, dia punya road ni dalam bentuk bulatan. So you can see that actually kalau dia berada di ketinggian contoh dia berada di ketinggian ni sejauh h, dia punya ketinggian, dekat curve yang satu lagi pun, let's say bila dia ada dekat curve yang kat sini, kereta tu dia akan berada di ketinggian yang sama. Dia akan berada di ketinggian yang sama. So that sebenarnya kereta ni dia bergerak, dia punya path dia adalah horizontal, something like this. Dia adalah horizontal like this. Okay. Then kenapa saya bagi tahu ni? Disebabkan oleh awak punya AC now is something like this. This is your AC. AC awak dah horizontal. Okay, what happen? Bila kita cari all the forces on the car, you will have weights. Of course, you akan dapat weights. mg. And then you akan ada R. Dan sekarang ni kita nak paksi kita ikut A kita. Okay, paksi kita ikut A kita. So, kita akan dapat X axis dekat sini, Y axis dekat sini. Okay, dekat situasi ni kita tak payah sengitkan. Okay, kita tak payah sengitkan awak punya paksi tu sebab memang kita nak follow the A. What happen here, you will have something like this. This is your mg. And this is your R. Okay. Tadi kan dia bagi sudut kat sini kan. You can see that sudut ni, kalau kita tengok kat sini, this is your R. This is your, ni paksi Y awak, ni paksi X awak kan. So, you can see that this one, sini dengan sini, sudut dia sama. And then, awak akan nampak dia kat sini. Sini adalah 90 degree. And sudut ni yang akan sama dengan sudut bend curve. Which is, awak akan dapat sudut yang bertangkup dengan paksi Y. Okay. Sama dengan bend curve tersebut. Alright, for here, yang awak perlu resolve adalah R lah. Sebab R tu tak follow awak punya paksi. Bukan lagi weight. Kalau yang chapter 3, kita resolve weight kan. Chapter ni kita resolve R. So, what happen here? Your AC is in x-axis. Okay, your AC is x-axis. You will have something like summation FC awak adalah summation of X. Fx. Which is R sin theta. Okay, what happened here? Your FC is equal to MAC. Your FC now adalah R sin theta equal to MAC. Same here, you will have summation of Fy equal to 0. So, from the summation of Fy, you can get R cos theta equal to minus mg equal to 0. So, we get R cos theta sama dengan mg. So, here there is no friction because if there is friction, the calculation could be complicated. But for your knowledge, if there is friction, your friction should be downward. Sebab apa? Bila awak berada di atas bend curve, your car tend to move upward. Jadi, friction dia melawan pergerakan, ia adalah ke bawah. Okay?